So today we're going to be looking at whether the Arctic Alpine 11 passive CPU cooler can handle the Core i5-7600T 35-watt CPU. And if not, will Undervolting help it out? So what is the Alpine 11 passive? Well, it's basically a 527 gram lump of aluminium which is designed to cool 35-watt Intel CPUs, all the 115X sockets it will fit, in a fanless or passive setup. And unlike many other passive coolers, and indeed some non-passive coolers, it's both cheap. It retails for around $15 or £15, and it's pretty simple to install with some basic screws, bolt through from the back of the motherboard into the CPU cooler itself. It normally comes pre-applied with MX2 thermal compound just here, but as this one has been used before, that's no longer there, and we'll just be using some Noctua NTH1 today just to add some thermal compound there. As for the CPU, this is the Intel Core i5-7600T. It's a 7 series processor. It's got 4 cores, no hyperthreading. It has a TDP, or thermal design power, of 35 watts. And that's lower than the normal Intel i5 CPUs. They're typically 65 watts or 95 watts for the K versions. It has a T-junction of 80 degrees centigrade, which means when it hits 80 degrees centigrade it will start to throttle to protect itself and the system. So why, if the cooler is rated at 35 watts and the TDP of the CPU is 35 watts, would things not work? Well, let's take a look at how Intel defines TDP itself. So thermal design power should be used for processor thermal solution design targets, but TDP is not the maximum power that the processor can dissipate. So though a TDP is a guide for the cooling solution, if you push the CPU hard, it could use significantly more power than the TDP suggests. If you do that for an extended period, you'll overload a cooler, particularly a passive one. Now add to that the fact that Intel has a whole range of T-series CPUs, from lowly 2-core 2-thread Celerons right up to 6-core 12-thread i7-8700Ts, of which all are built on the same 14nm lithography, and this suggests that something doesn't quite add up. Logically, we'd be thinking that the lower ones either need to run a lot less than 35 watts, or higher ones push well past the 35 watt limit, or perhaps both. So we're going to have a look at that a little bit today. Now overall, the T-series CPUs typically a little bit more difficult to get hold of than the normal CPUs. They're not sold in a box with a cooler. They're typically sold as a bare CPU, often referred to as a tray, and only a few merchants tend to sell them. They typically arrive a little later to the party than the standard CPUs as well. They're not as high demand, and they're often more expensive as well, even than the K-series versions. So combine that with the current supply issues that Intel have had with their 8 series and 9 series CPUs, and it's almost impossible currently to get hold of any 8 series T CPUs, and there aren't any 9 series ones yet available. But this i5-7600T is available, and it should provide a good workout for the cooler and also more than enough performance for most general uses. So we have everything set up now. We have the Gigabyte Z170N Wi-Fi motherboard installed on this open bench table. We've got it in an open bench basically to allow the passive cooler the best chance to cool things down with free airflow. We have the processor already installed, and then we have the Alpine 11 passive block on top of that. As you can see, it's a large block of aluminium in comparison to the Mini ITX motherboard. We've got one 4GB DIMM RAM installed here, and a crucial MX500 SSD. Underneath we have a power supply. It's not a passive one, but in the orientation it's in, the fan is right at the bottom and it will be expelling air to the right hand side, so it's going to have no effect whatsoever in terms of airflow over this passive cooler. And the plan is to actually run this through multiple stress tests. I'm going to use Ada64 for that, as that allows you to do both CPU testing and CPU plus GPU stress test. That one we believe is going to put more heat into the chip and therefore more into the cooler. So we'll expect to see different capabilities here of it being able to handle those loads. What I'm going to run is a couple of runs of each of those so we can get averages, just to make sure there isn't any anomalous stuff in between. And then we will also do some undervolting as well. So we'll run it at the standard voltage that the motherboard sets the processor up for when you install it, but we'll then lower the voltage as well via undervolting, see how low we can go, see what effect that has on the amount of heat that the processor generates or the power it uses, and therefore the cooling capability of the cooler on top of that. What we tend to find is when you're using a block like this, it takes quite a long time to cool down if you put a lot of heat into it. So to help with that, in between runs, I'm just going to use a standard 120mm fan, which I will plug into the CPU header, fan header, and use that to help cool down the passive cooler in between runs to speed things up. That way the ambient temperature is less likely to have fluctuated and therefore shouldn't be affecting the results between different runs. So we should be comparable. So what I'll do now is I'll plug in the peripherals and then run the tests and come back and show you the results. So before we jump into the results, just want to quickly run through the tests that we actually did. We used Ada64 and we did some CPU stress tests there, and that actually included the CPU, FPU, cache and memory tests. Then we added in the GPU piece as well to get a CPU plus GPU stress, and we ran both of those twice to get an average, or just to make sure there's no anomalies between two different runs. Ran Prime 95 with it set to small FFTs to make sure that we were chucking as much heat through as possible. Ran Cinebench R15 just as a quick performance check, and also ran the machine idle for several minutes to check the power output when idle as well. And what we did in terms of voltages was we set it up initially with the auto voltage, and for this CPU that would typically show it at about 1.12 volts. This would then fluctuate depending on what the machine was doing, so it would intelligently drop the voltage much lower than that when it was idle. We'd also then ran quite a few different undervolting tests to see what difference that would make, and what we found, the 0.98 volts we were able to boot into Windows, but Prime 95 failed every time. At 0.985 again could boot into Windows, but sometimes we'd get errors in Prime 95. And then 0.99 was the first time we actually managed to get a stable run of both Windows and Prime 95 and the other tests, and also at 1.0 that was obviously stable as well. So if we now move on to the results and have a look at, so what this chart is showing us is how much power the whole setup was pulling from the wall whilst it was doing various tests or running idle at the different voltages. So what we can see there is that the auto voltage, the red bars here, when we were doing the CPU test, it was pulling 51, CPU and GPU at 67, and Prime 95 as well was at 68 when that was being run. So that kind of gives us a bit of a clue that we might be starting to struggle to cool some of that with the 35 watt CPU cooler, even though this is the whole system, not just the CPU piece. When we drop down to 1 volt, we've got significant drops in terms of the total power being pulled. So 44 for the CPU, 60 for the CPU and GPU, and the Prime 95 was 57. So, and when we went to 0.99, it dropped very slightly for those tests. If we look at the idle though, for idle when it was set to auto voltage, what we see there is because it's intelligently managing the voltage, it's dropping much lower than the default setting that we have for while we're undervolting. When you undervolt, you set a stable voltage on this motherboard, and when you're doing the auto one, it's self-managing, so it's dropping to a much lower level. So you can see as idle there is only pulling 19 watts from the wall, whereas the two undervolts are pulling 25. So that's something to bear in mind depending on what you're planning to do with the machine. If you want it to run 24/7 and it only occasionally will be stressed in any way, shape or form, you probably want to leave it at auto settings. But if you're planning to use a machine heavily and it could be utilised for a long period of time when it's stressed, you probably don't. You probably want to look at undervolting it rather than letting it run at the auto, because we're seeing quite a few bits of changes there. So if we then move on to the results that we see in terms of the temperatures. So this first set of results is for the CPU and GPU stress test, so this is where we're putting the most heat through. And we've got a T-junction marked on there, which is the 80 degrees centigrade, where the processor will throttle itself to protect itself and the overall system. The red lines there are again the auto voltage, and the blue are the 1.0 voltage. We haven't got the 0.99 on there because it was so similar to the one, it wasn't worth cluttering up the chart with it. What we can see though is after about 6 minutes, this CPU was throttling going through this test, the auto voltage, and it was still throttling in about 11 minutes when we'd even undervolted it. But you can see there's a significant difference between those two. If we then move on to the CPU stress test, so again, this is a lower power requirement. You can see the two different runs there for auto. There is a different difference there, you can see them there. And what we're seeing, even just using the CPU stress test, it was throttling it by 15 minutes into this to the run, whereas with 1.0 voltage, it was able to go through the whole 30-minute test here without throttling, and it finished off at around 73 degrees, and it was pretty stable by that point. It would probably go up another degree or two over the next 30 minutes or so, but it was able to manage that level of power. So, what conclusions can we draw from all of this? Well, from my point of view, if you're planning to use the i5-7600T along with the Arctic Alpine passive cooler, you can do, as long as you undervolt the CPU on the motherboard. You should be absolutely fine for normal day-to-day usage. If you want to use it for doing some basic gaming, or you're going to be stressing it in some other way, you're probably going to run into problems. It's just going to generate too much heat if you're consistently running it flat out. But as long as you undervolt it, you put it in a decent case, so you've got plenty of options for the air to move through convection, you should be absolutely fine. You'll have a decent powered little computer.